I'm going to do a quick introduction of PROLOG for Programmers using J.R. Fisher's tutorial. It's on this web page here. One thing to notice is that we strive to do declarative programming. One form of declarative is relational programming. PROLOG was one of the first attempts at relational programming. Mini-Canran is the current manifestation of relational programming. I happen to be using Emacs org mode, and I'm going to probably use SWPL WI PROLOG, although I've used gprolog a lot also. Let's have a look at the figure. It's listed in that article. It's basically 5 nodes forming a network, and there's connections between the nodes in the various ways that are shown on this diagram. The diagram shown can be described as a PROLOG fact base. PROLOG, we would say that there's an edge from 1 to 2. The period acts like a semicolon in many languages. These are all relations. They're basically just straight out fact constants. And if you look through the rest of it, you can get the idea of what's going on here. If we look at the fact base, we see that there's an edge from 1 to 2, but it doesn't say that 2 is connected to 1. We can add a basic relation that shows this relationship that 2 nodes are connected if there's an edge between x and y, or if there's an edge between y and x. In PROLOG, we can write this basic relation a different way, which is to use a semicolon operator. So basically we're saying connected is edge of xy or edge of yx. In PROLOG, it is conventional to put all the OR terms separated as separate relations, or in this form where there's a semicolon between them, and type relations are done with commas. We'll see that later. We can infer further connections by adding PROLOG rules using, guess what, divide and conquer. There's the programmer do it kind of style, and then we can prologify it and turn the relations, the code, into better relations. Any attempt to solve this problem breaks down into 2 main problems and 1 envelope. I call the envelope around the whole thing the top level. There's a base case that says how we know when we're finished, and the recursive case. We'll start looking at the top level case. Basically, having a relation that signifies the path between A and B, and we write the path into a result called path. Fundamentally, every path starts out with square brackets in PROLOG mean list. So the basic path always has A in it, since that's where we start, and then we infer new paths between A and B as we go. If we look at the base case, it says that at the most basic level, if there's something that satisfies a connection between A and B, then we're done. And we just glue the result B onto the path. This is the way you write list consing B onto the front of B, and then we're putting it into the called result path. In the recursive case, we look for connections between A and B. We keep a prior path around, and we keep the result path. We invent a new node, and we call it C, and we look for a connection between, if A and C are connected, and C is not equal to the final result B that we want, and C is not a member of the prior path, then we cons C onto the prior path, creating a new path, and then we recur. We try to find connections between C and B and we produce a resulting path, and we keep a prior path around. Now we'll look at how to write these relations in better PROLOG form. We'll look at the top level, the base case, and the recursive case separately. Now looking at the top level in PROLOG form, we take the do-it style and rewrite it in PROLOG this way. Programmers are used to writing a function signature followed by how to get there, how to do it. Whereas in PROLOG, everything is a relation, and that's not actually a function signature, it's just a shorthand for whatever is on the right-hand side. So the left-hand side really is just a truism. It says when the PROLOG run is finished, then this will be true, and here's how we infer that things are true. In this case, we don't need a variable that assigns the list of containing only A into a temporary variable called basic path. We can just stick it directly into the relation and get rid of this. In fact, the equal business in PROLOG needs a little bit more looking at. I won't dig into it, but try not to use it. Likewise, the base case in PROLOG folds our original code, which kind of looked like this with an equal sign, into a relation that says everything in one fell swoop, that we can infer the path from A to B, and the result is B put onto the resulting path, or the resulting path is the previous path with the result B put onto it, only if A and B are connected. Again, this doesn't look like what programmers are used to, because we're showing things that programmers think of as do-it code, consing things on the left-hand side. In fact, this is still a relationship that shows that infer path is true, and we had a prior path, and that the thing we called the resulting path is broken up into a head and a tail. A head where the head is the node, and the tail is the previous path. And when we continue writing it this way, we can actually do more interesting things, like we don't actually have to supply A and B. We can ask, given a path and a prior path, what were the A and B's that satisfied that relationship? Likewise, the recursive case of prologification takes the old do-it style and writes it as a single relation that's recursive. And here we've gotten rid of variables like this. In this particular case, I took prior path and renamed it to visited, which makes more sense to me in the final result. We've dropped from 5 lines to 4 again, this side is the abbreviation for these 4 lines. So if we can show that these 4 lines are true, then this relation is true. And PROLOG will find all of the matches for that relation. And in PROLOG, what we'll see is we can actually run some of this code in PROLOG. And we will see that it backtracks over. The code gives us one solution. If we give it a semicolon, it gives us another solution. If we give it another and keep doing that until it runs out of solutions, then it stops giving us solutions. I've taken all of the code we've written so far and the facts and put them into a single file called path.pl. The extensions .pl and .pro are the ones favored by the two prologs that I use, SWI prolog and G prolog. Now I'll take this prolog file and load it into Prolog. So we'll switch to the terminal. We'll run SWI prolog. And to load a file, I use the command called consult. And we don't need to give it a path name. We do have to remember the dot. And that loads the file. We can do simple queries on the fact base. For example, we can ask to see if there's an edge between 1 and 2. And now it says true, there was. I'm going to put in a semicolon, and then it'll say there are no more edges between 1 and 2. I can try an edge between 2 and 1, and that says there isn't any. There aren't any. Now we can use the most basic query that we had, the basic relation, which is connected 2 and 1, and that returns true. We can say connected 1 and 2, which should be true, and it is. Now we can try something more interesting. We can ask for what is the path between 1, 5, and we'll put the result in something called P. And it says that you can get there going from 5 to 1 to 2 to 1, or from 5 to 3 to 2 to 1, or 5 to 4 to 3 to 2 to 1, 5 to 4 to 1, 5 to 3 to 4 to 1, 5 to 3 4 1, 5 3 1, 5 4 3 1, 5 2 3 1, and that's it. Note that in Prolog, logic variables are always capitalized. Everything else is lowercase. So if I say path 1, 5, big R result, then it has no problem finding it. If I say path 1, 5, lowercase result, then it fails immediately. I can also put some of these commands into bash scripts. Halt is the way to quit Prolog. I go up here and I think I've created a file called gpath for running gprolog. If I run that /gpath, then it'll consult the file path.pl, and then it'll leave me ready to do a query. So I can do 1, 5, capital R, and then it'll give me the results. Halt. I can do the same for SWI prolog. I've created a bash file called swipath.bash, and it's got a slightly different command line syntax, and we'll try running it. Change this /swipath, and it leaves me ready to do a query. It's consulted the file called path.pl, and it leaves me ready to do a query. Like that. And same thing, halt, period. Halt is the way you finish, and then you all have to remember the period. SWI prolog has the -q modifier, so I'll say -q. I'll do a \, which is shell syntax, to continue a line, and modify the file this way. I then run it again, and there it is, ready for me to put in a query. You can even I'll halt this again, halt. You can put the query in as a further command line argument, -g path 51 big R, and we can try that. Guess what? It ran the query, but it didn't show us the result. Now we'll retry that with rewriting the query to have an output. So we're going to collect all of the results R of the query path R into a bag called B. Then we're going to write B onto stood out, and then we're going to cause a new line. And if I got that, we should be able to run it. There it is. Ta-da! And I forgot to put, I can put a halt at the end of that. Like this, -g halt. Let's try that. And that's the whole query, and it finished. Things get more interesting if we write out the facts as JSON instead of PROLOG fact-based format. I'll make modifications to the shell script. Here we consult path.pl. I've added the line that uses the module called JSON. Then we do the bag of, and instead of calling, we call JSON write. This is stood out, user output in PROLOGese. The bag and the NL, we've saved it, and then we try it again, and there we are, its output is JSON.